Hey guys, I hope you are all doing well. Welcome to my channel Beloved Academy.
In today's video, we are going to be focusing on differential equation. What is a differential equation? A differential equation is an equation that consists of a derivative of a dependent variable and an independent variable. For example, let us look at this equation. Y is equals to x raised to the power of 2. In this equation, x squared is the independent variable, while y is the dependent variable, because any increment in x will lead to corresponding increment in y. Now, what is a differential equation? A differential equation is an equation that consists of an independent variable x and a dependent variable y, and the derivative of the dependent variable with respect to independent variable. So in a simple sense, a differential equation is an equation that consists of the derivative of a dependent variable with respect to independent variable. Now, let us proceed to the order of differential equation. When we talk about the order of differential equation, we are talking about the order of the highest degree of the derivative of that particular differential equation. Let's assume that we are given a differential equation d square y all over dx square plus y dy over dx equals to 0. Of course, this is a differential equation. Now, what do we do when we are told to find the order of this differential equation? Don't forget, from our definition, the order of a differential equation is the order of the highest derivative of that differential equation with respect to dependent variable. Now, if you look at this, what is the highest order? The highest order in this place is the square y all over the x square. So the order of this differential equation is 2. If you look at this is the highest order. That is, this is the maximum derivative of in this differential equation. As you can see, this one, the y dx only signify that this equation has been differentiated once. But when we proceed to this, when we look at this, it means that this differential equation has been differentiated twice. Therefore, the order of this equation is the order of the highest derivative. And if you look at this is the highest derivative. This is the maximum derivative, because it is the square y over the x square that tells us the amount of time, the maximum amount of time that our equation have been differentiated. Therefore, the order of this differential equation is 2. Now, I'm going to be giving you a numerous example on this question so that you'll be able to differentiate between the order of an equation and the degree of a differential equation. Find the order of differential equation for the question 1. Let's start with question 1. The square y all over the x squared plus 6 the cube y all over the x cube plus 1 equals to 0. Now, let us find the order of this differential equation. Don't forget the definition of order of differential equation. The order of differential equation refers to the order of the highest derivative of the dependent variable with respect to the independent variable. If you look at this, we have in our equation, we have the square y all over the x square plus 6 the cube y all over the x cube, this is cube, plus 1 equals to 0. And from our definition, we know that the order of a differential equation is the order of the highest derivative, order of the maximum derivative. Now look at this question. You can see that the square y over the x square tells me that this equation have been differentiated twice. But I see another order that tells me that the differential equation has been differentiated 3 times. So my focus will be on this highest derivative. So I'm going to be having this. This is my highest derivative. So the highest derivative, the order will be, order of this equation will be order equals to 3. The order of this equation is now 3. Now let's proceed to question 2. We have here the square y over the x square plus 1 equals to 0. Now, what is the order of this equation? Yeah, the order is 2. As you can see, the highest derivative here is 2. So the order of this equation order is 2. So let's proceed to the third question. 2 the square y over the x square plus the cube y all over the x cube minus 5 equals to 0. Now look at this question. What is the order of this derivative? The order of this differential equation. Oh, no. Okay, question 3, we have 2 the square y over the x square plus the cube y all over the x cube minus 5 equals to 0. Now, look at this differential equation. What is the order of this differential equation? You will agree with me that the order is 3 here. The order is 3 because this is the highest derivative and the order here is what 3. So the order of this differential equation is 3. Now for question 4, I have the square y over the x square into bracket raised to the power of 4 plus the y over the x minus 7. Don't forget that the the order of a differential equation is the order of the highest derivative of the dependent variable with respect to the independent variable. So the order of the highest derivative here is the square y over the x square, and the order of this equation now is order of this equation is 2. Don't focus on the power which the derivative is raised to. Focus on the derivative itself. So the order of this equation for this differential equation is order 2. Now, okay, let's proceed to question number 5. We have in here the cube y over the x cube plus equals to the y dx plus 2. Of course, what is the order of this differential equation? The order of the differential equation is 2. Yeah, the order is 3. The order of the differential equation is 3. Now, for question number 6, what is the order of this differential equation? Yeah, the order is 4 because this signifies that this differential equation has been differentiated 4 times. So the order is 4. The order is 4. Order 4. So let's proceed to the next question. I have here dy dt is equals to 2t plus 6. The order here is 1 because this signifies that this equation has been differentiated only 1 time. So the order now is 4 and the order now is 1. Order is 1. So now let's proceed to question number 8. I have here the square y over dt square into bracket 1 over 2 equals to 4y dt plus 5. Now, what is the order of the highest derivative here? The order of the highest derivative is 2. So this signifies that this equation has been differentiated twice. So the order is 2. Order is 2. Order 2. So that is how to find the order of a differential equation. Now, the next concept that we are going to be focusing on is the degree of a differential equation. Okay, let us proceed to the next concept of differential equation, which is the degree of a differential equation. Now, the question goes thus: find the degree of differential equation, and they gave us various questions that we should find the degree of the differential equation. Now, what do you understand by the degree of differential equation? The degree of a differential equation is the highest power of the highest derivative of the differential equation. That is the exponent of the highest derivative. The power of the highest derivative, that will be the degree of differential equation. Now, if you know the order of a differential equation, you can easily compute the degree. You can easily find the degree of the differential equation. Now, let's take for instance, let's look at this question number 1. We have the square y all over the x square plus 6 the cube y all over the x cube plus 1 equals to 0. We can easily say that the order of this equation is 3 because the order is the order of the highest derivative of the dependent variable. So with respect to independent variable, so the order of this differential equation is 3. The order is 3. Order, we have 3. Now, what is the degree of this equation? What is the degree of this differential equation? Don't forget, The degree of a differential equation is the highest power of the derivative. The highest power of the highest order of the derivative. That is the degree. And it can also be expressed. You can also say it like this: the exponent of the highest derivative. That is the degree of this equation. Now look at this. You can now, since this is the order, this is the highest derivative, so the power of the highest derivative is 2. So the degree here is what? 2. The degree is 2. Now let's go to question number 2. What is the order of this question number 2 of this differential equation? Of course, the order is 2. Order 2. Now, if you look at this question, what is the degree of this differential equation? You can see that the highest power, the power to which the order is raised to, that will be the degree of the differential equation. So the degree here is 2. So degree is also 2. Now let's proceed to the third question. We have the square 2d square y over the x square into bracket d cube y all over the x cube minus 5 equals to 0. Now what is the degree, what is the order of this equation? After getting the order, you proceed to look for the exponent of the order to get your degree. Now what is the order of this equation? The order is the highest derivative, and the highest derivative here is the cube y all over the x cube. So the order is 3. Order here is 3. Order 3. Now the degree is the highest power of the highest derivative. The power of the highest derivative. If you look at this, the power of this is 1. So the degree is 1 here. So let's proceed to the fourth question. What is the order of this differential equation? Of course, the order is 2. Order 2. And if you look at if the order is 2, you have known the highest derivative. Now, what is the exponent of the highest derivative? The exponent is 4, so the degree is 4. The degree of this equation, the degree is 4. Now, let's move to question number 5. We have here the cube y over the x cube raised to the power of 4 equals to dy dx plus 2. Now, if you look at this, you can easily identify the order because the order is the highest derivative. So the highest derivative here is this the cube y over the x cube, which signifies that the order is going to be 3. So we have here order 3. Order 3. So the order is 3 here. Now you have known your order. The exponent of the order, the highest power of the order will be the degree. So if you look at here, I have 4 here. So the highest power is 4. So the degree here is 4. Degree is 4. Now let's proceed to question number 6. What is the degree of this? What is the order of this differential equation? Of course, you agree with me that the degree of this, the order of this differential equation is 4, because I have that the highest power of the highest derivative, the highest order of the derivative is 4. So the order is going to be 4. Order 4. But what is the degree? The degree is the exponent of the order. The degree is the exponent of the order of the differential equation. So we are going to be having the degree here is 3. So degree is 3. Now we proceed to question number 7. We have dy dt raised to the power of 2 equals to 2t plus 6. And since we are only having the order here is 1, which signifies that this differential equation have been differentiated only one time. So the order is 1. Order 1. Now, what is the exponent of the order? The exponent is 2. So the exponent here is 2. So the degree is 2. Degree 2. Now, in the question number 8. Now, I want to pay attention here. We have the square y over dt square raised to the power of 1 over 2 equals to 4 dy dt plus 5. When you want to take the order of a differential equation, you focus on the highest power of the derivative. Derivative with the highest power, that will be the order of the equation. Now look at this. We have the square over dt square. So the order of this can be easily determined. The order is 2. Okay, let's proceed to the next question. Question number 8. The square y over dt square raised to the power of half equals to 4 dy dt plus 5. Now, okay, I've taken the order. Now, what is the degree of this differential equation. Now, I want to take note of something. If you want to find the degree of a differential equation, the differential equation must be in a polynomial form. That means that the power of the differential equation must not be a fraction. The power of the differential equation must not be a fraction. As I have here, the power of this differential equation is in fraction. So how do I take the degree of this differential equation? The first thing I'm going to be doing is to change this differential equation into polynomial form. How do I take, for example, now I'm having 1 over 2 here. If I want to convert this equation, this differential equation number 8 to polynomial form, I'm going to multiply both sides of the equation, both sides of the differential equation by the inverse of the power. For example, now I'm having 1 over 2 here. If I want to change this differential equation into a polynomial form, I'm going to multiply this power by I'm going to multiply both sides of the equation by 2 over 1. So I'm going to be having dy over dt, the square y over dt square raised to the power of 1 over 2 multiplied by 2 over 1, because the inverse of 1 over 2 is 2 over 1. So I'm going to be having multiplied by 2 over 1 equals to 4 dy all over dt plus 5 multiplied by 2 over 1. Now, if I multiply 1 over 2 multiplied by 2 over 1, so 1 over 2 multiplied by 2 over 1, that is 1. So I'm going to be having the square y all over the x square, dt square is equals to 4 dy over dt plus 5 raised to the power of 2. So I can easily take the degree of this differential equation. The degree of this differential equation is the highest power of the derivative. Now, if you look at this is the order of the equation, which is 2. The degree, the highest power of the order is 1, because when I multiply this by 1, I'm still going to result into this. So the highest power is 1. So the degree of this equation will be what? 1. So what I'm talking about is that when you want to take the degree of a differential equation, you focus on the power of the exponent of the order. And when you want to take the order of a differential equation, you focus on the highest power of the derivative, the maximum derivative of the differential equation. That will be the order of the differential equation. But when you want to take the degree of the differential equation, you focus on the exponent of the order. That is the power to which the order of the differential equation is raised to. Thank you very much for watching the video.
On this channel, you will find information, concepts explanation, tutorials video with detailed explanation that will assist you in gaining more knowledge and insight. In addition, our channel features past question, solution to questions you are likely to encounter in exam, solution to all past questions. Please kindly subscribe. All questions are solved with simplicity.